More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hi everyone, and welcome back to Mathnasium Schoolhouse. My name is Sandra, and I, of course, will be your instructor for today. And for those of you joining me, I see Srikar. Hello, hello. Thank you for being our first student on board today. For those of us joining me today and all of us tuning in, we're looking at the topic of finding a missing number. And I kind of left it very general there because that's exactly what I want to do today, is just explore so many different math questions where we're simply looking for a missing number. And I didn't want to maybe make it too specific with addition statements or subtraction, multiplication or division, because the fact is we're going to work with all four of those operations today. Not just that, we're going to take it a step further. Not just whole numbers, but also decimals, fractions, and for those of you that have explored integers, we're going to look at some negative numbers as well. All right, so there is something that's been new this week for our Schoolhouse lessons is there is a follow along practice page. It's in the same document, the same PDF, which was just shared in the comments. So if you'd like to open that up in a separate tab, go in your browser, go ahead and do that, and you can follow along. If you don't feel that you can concentrate on the two different tabs, no worries. I'll, of course, write out the questions on the board, but you can feel free to open that up and follow along with the questions that we'll be exploring today. Okay, so let's go to my whiteboard here, and let's start with a few questions. So I'm going to give us a few warm-up questions. Some of you might find this pretty simple, others might not. That's the beauty of these Schoolhouse lessons. Everyone is welcome to join us with various levels. And so let's see how we can tackle this problem. Hello, everyone that's joining us today. It's lovely to see all of you. So go ahead and tell me what would be in this blank, what number here, if when I read this out loud, it tells me 7 plus some number, which would fill in this blank, is equal to 10. How would I possibly get that? I see the number popping up. It is, in fact, 3. And we're not going to focus too much on statements like this, but for those of you that maybe don't see that too clearly, it's as simple as saying, well, if I have 7 of something, right? 4, 5, 6, 7. How much more do I need to add to this to get a total of 10? Well, let's see. If I have 7 here, I can add one more to make 8, another to make 9, and of course, my last one to make 10, which means that I added a total of 3 to my original 7, which is why I have a 3 here, okay? If we're all on the same page on that question, let me give you maybe a few more here. So what if I changed this to be a 10, and I had a blank here, and this was a 0? What would that be? It's not a trick question, I promise. Right? Well, if I have 10 and I want to get to 0, what do I possibly have to add? Oh, sorry. Let's make that 10 for now. Let's make that 10 for now. I'll save that question for another time. What do I have to add to 10 to make it, just to keep it as 10? Ooh, I like the comment that I just saw. Okay, negative 10 was the answer to the previous problem. That is absolutely correct. I'm going to save that for just a second. But for those of you that are just seeing the revised question, it would be 0, right? If I already have 10, I don't have to add anything to it to still have that 10 that I want, right? For those of you writing a negative 10, I love it. That's great. Keep that in mind for the next problems that will come up with our integers. I did see in a previous comment that disappeared for me right now, someone had written in the previous problem, we had 7 plus 3 is equal to 10. And somebody told me to think of this as, or someone told all of us, we can think of this as 10 minus 7. Let's keep that in mind for some of the next questions that we look at. I love the way that this was brought up and how it relates to this question here. So we could have used the counters that I used here to figure out that I was missing 3, or we can kind of work with subtraction, which is the opposite of addition, to figure out that answer. So we're going to keep that in mind. I like that that was shared. Put this away. Let's just do a few more warm-up problems before we get into some of the more complex problems. I'm going to pose a few more here. Go ahead and answer them. And I'm going to have, there we go. And maybe let's do one more. So go ahead and share those answers with me. I'll give you a few seconds to do that. Okay, I see an 8 popping up. I like that. That is true. 10, we kind of looked at this in some previous lessons, if you've been with us throughout our journey here on Facebook Live. 10 plus some number gives me 18, right? 18, which means that there is an 8 that's missing here, right? 10 plus the 8 gives me 18 if we sound that out. Similarly, if I have 14, what do I subtract from that to get back to my original 10? Well, if I follow the same pattern that I hear when I read out this statement here, I know that I'm missing a 4, which I'm seeing in the comments. Beautiful. And so let's use that same pattern here. Something, and from that I subtract 10, so something minus 10 gives me a 7. What could I possibly do there? I'm seeing the answer 17 pop up. That's right. So if I listen to that again, 17, and I take away the 10, I get my 7. And again, if that's a little bit confusing, you can pull out your counters. All right. All right, so let's carry on. Let's move to some integers. For those of you that haven't explored this yet in the classroom, don't worry about it. This will be something that you get to explore, and hopefully you can follow along with some of our reasoning here. So I'm going to move away from just positive numbers. No worries for being late. I'm going to pose a few problems here. So for example, I'm going to write a few of them down. Go ahead and think about them. There's that original question that I had. Think about them for a few minutes. I'll write down maybe one more here. All right. And for those of you that know something about negative numbers, how about you help the rest of us out and tell us what you know about negative numbers. Or you might have heard them referred to as integers, which are the combination of the positive and negative numbers. What do we know about them? So I'll read some of these statements out here. -7 plus something gives me a -10. Okay, so maybe if you hear it, that might be a little bit more helpful for you. -7 plus something gives me a -10. 10 plus something gives me a 0. No negative numbers there, but still a pretty weird question to be asked, so possibly some negative numbers would come up, because how can I add something to a whole number and get 0? Kind of contradicts what we know about addition. And then I have a -15 and I want to add something and get to 10. How do I do that? Yeah, for some of you that don't know negative numbers, that's completely understandable. You learn that towards the end of probably towards your middle school levels in most schools. Okay, so let's see what we can do here. I see some numbers popping in for those of you that are comfortable with negatives. I like it. I see that the first one is coming in as -3. I do see a +3. I don't know if that's a mistake or not. Okay, so another way for those of you that don't know too much about negative numbers, and in the future, we'll definitely have a schoolhouse lesson available for you on them. Another way to think about negative numbers is to think, okay, I'm missing 7, right? I don't have 7 counters, I'm missing 7 counters. So if I'm missing 7, how much more do I have to miss altogether 10? To not have 10 counters. For now, I don't have 7. How many more should I not have? I know that's a weird question. To not have 10 altogether. -3. Thank you, Tracy, for that correction. Beautiful. But that's absolutely correct. Yeah. So I would need to be missing another 3 to have altogether 10 counters that are missing, right? If I think back to that positive statement that I had before, and another way that you can actually do this without these counters is to look at two-sided counters, and we can think of, let's say, the negative numbers as red and the positive numbers as yellow. So if I'm missing 7, 1, 2, 3, 4, 5, 6, 7, okay, I'm going to put these to the side. I need to have altogether 10 negative numbers. I need to be missing 10. So if I miss 3 more, I have altogether 10 that I'm missing. And I just saw the beautiful comment shared by some of my helpers, a beautiful explanation of negative numbers as well, which is in fact true. It's numbers that are less than 0. So as we've been working with numbers that are greater than 0, this is what happens if this is why I keep saying missing, right? You have less than a 0 amount. Okay. So let's carry on to the next one. I know this was previously shared, so I am going to just include it here. If I have 10, but then 10 go missing, I really have 0. That's another way to look at this if you're not too comfortable with negative numbers just yet. If I have 10, let's say I had 10 yellow ones, but then they all turned red, and then I was missing all of them, I would have 0. It's like a mirror image of the positive numbers. Beautiful. Yes, we'll look at a number line in just a second. And what if I have -15 here? So I'm missing 15 cookies, let's say. I'm missing 15. I want to have 10 altogether on my plate. What do I need to add here? I don't know that I saw this just yet in the comments. I'll give you a few seconds to think of that. For number 3 here. Well, if I'm missing 15, and let's say my friend gives me, or let's say another way to look at this situation just from the problem that I posed to you, let's say I owe my sister 15 cookies. If my brother gives me 25, I give back those 15 to my sister, I have 10 left over, right? So there are some missing number problems with some negative numbers. And for Surkar, I believe you helped some of us out by looking at negative numbers as mirror images of positive numbers, which I know it's a little bit blurry in my camera, so bear with me here. But one way that you might have already been presented with negative numbers, with integers, is through a number line. And as my beautiful helper helped me out in the comments, if I have my 0 here, if you can think of it as going forward, the positive numbers, you're counting up 1, 2, 3, 4, 5, 6, all the way to 10 in this case. And if I go backwards, if I count down, or if I start owing an amount, or I'm missing some amount, I'm actually going into different numbers, which are just the negatives of those whole numbers. So -1, -2, -3, -4, and so on. All right? So maybe we can use that for another problem. Let me pose a few more for you here. And then we'll jump into some decimals and fractions before we look at other operations. So let's look at, I'd love to give you 10. Subtract some amount gives me a -1. So that's an obvious one. Then I'd like to also give you a -12 minus some amount gives me a -15. And let's do maybe 2 more. A -10 minus some amount equals 0. Another version of this question. And let's do maybe one more. 10 minus some amount gives me -10. Again, take a few seconds to think about these problems here. I'll put these to the side. go ahead and share with me any of the answers that pop up in your mind. Feel free to tackle any of them that you're most comfortable with. I see a negative 11 popping up with some question marks. I love the effort. Thank you for trying. Yep. So I'll address that one maybe first. Why not? Yeah, for the first one. Okay. So maybe not negative 11 just yet, but maybe 11 itself. There we go, Yuri. Thank you for sharing that. Very, very good try, Mimi. Very, very close. Great job, Dennis. Right? And again, you might have been introduced to integers in many different ways. Anything that makes most sense to you. Again, if you want to think of it as owing an amount, missing an amount, or just think of a number line, you can definitely do that. If I just show you on a number line as another method here, sorry for covering up the next problem. So let me just do this really quickly. So the way that you would use a number line, if maybe you forgot even, is if my original question was 10, so I start at 10, and I need to get to negative 1, how much do I have to subtract, or how much do I have to go back by to get to that? Well, that's when you pull out maybe another color and you start to see how much you're going back by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is why, oh, I apologize, Deborah, which is why the answer would be 11. All right, which is how Yuri, Dennis, and a few others got 11. All right, beautiful job. What about the second one here? 12 minus some amount gives me negative 15. And I think I saw it popping up. I think I saw it pop up as negative 3, positive 3. Some of you are going back and forth. Not a problem. But let's see if we can make sense of that. Well, I like to think of it as I'm missing 12 toys, 12 Lego pieces, right? Or I owe 12 Lego pieces to a friend, something like that. Or I'm a negative number, so I'm the left side of my 0 on a number line. Whichever way, if I want to get to negative 15, I need to still subtract 3. Not a negative 3, but a positive 3. And let's jump to this one here. If I have a negative 10, how much do I subtract to get to 0? I'll wait for you guys to catch up there. This one's a little bit of a tricky one if you're not too comfortable with negative numbers. Again, I don't want to focus too much on the negative numbers here, maybe just a review for some of you. I'm going to use a bracket. Well, maybe I won't. Let's not confuse everyone here. Yes, your car. I like what you wrote there. So you kind of changed up the question. Instead of 10 subtract 11, you said 10 plus negative 11. Very good job. Yeah, very nice. A great way to kind of play around with this statement and see what else could be true in that blank. Okay, I'm seeing some 10s, some negative 10s popping up. All right. So it is in fact going to be a negative 10. Yeah, very good. And what about this one here? Oh, maybe you guys are playing around with the different questions here. What do I get here? How much do I have to subtract from 10 to get to negative 10? Well, I not only have to subtract this positive amount, but I have to still pass by 10 more numbers on the left side of 0. So I'm actually subtracting 20, or I'm skipping over 20 numbers to get to negative 10, starting at 10. Again, different ways to look at it. But let's move away from negative numbers for now and jump to some decimals to find some missing numbers. So I'm going to remove this. Right? Again, there's more practice problems for you after today that you can use to see if you understood today's content. So 7, some of you might want to say 7.25. I'm going to be naming this as what it is, which is 7 and 25 hundredths. Okay, but this is this number here, and I need to add something to it to make that 10. So before I pose some more problems, let's start there. So here we're working with the still the same concept. I'm looking for the missing number, but I've just kind of complicated things just the slightest bit by including some decimals here. So give that some thought for a few seconds. What do we think here? 7 and 25/100ths plus some amount gives me 10. So I'll tell you what I'm thinking, maybe as you guys are writing down your answers here. I so badly want to say this is going to start with a 3 because I know 7 plus 3 is 10, but I know that I have a little bit more than 7 here. So that means I can't have a full 3 here. So where I'm going to start is to say, okay, I have a 2, and so I see the answer popping up, thank you. So this little bit more than 7 that I had, how much more do I have to add to it to make a full whole? Well, if I know I have 25/100ths, I know I have to add 75 more hundredths to make a full whole. Okay? And for those of you that maybe just like to jump to some calculation on your end, you might have jumped to just figuring out this in your head, which is essentially what I'm doing. I'm just kind of figuring out the parts more so than subtracting the statement. All right, let me give you a few more. I'm going to give you 10 plus some amount is equal to 21 and 75/100ths, and maybe one more. 6 and 85/100ths plus some amount is equal to 10. Go ahead. Yes, Ricard, very nice. Thank you for sharing. If you didn't know, adding a negative is equal to or is the same thing as subtracting a positive. And subtracting a negative is the same thing as adding a positive. Some patterns to observe when you work with integers a little bit longer. So what do we add here? We're trying to find the missing number. Okay. This one's maybe a little bit that much easier because you're just trying to figure out what do I have to add to a 10? And 10, I often say, is such a friendly number. Anytime you can work with 10, go ahead and do it. So if I want to get to, yes, perfect. If I want to get to 21 and 75/100ths, I need to be able to add a 75/100ths here. So I know that's going to be part of my answer. And so then I'm just left to ask myself, well, 10 plus what number gives me the 21 wholes? You guys are wonderful. You are telling me it's 11, which is exactly right. Perfect. And what about this one down here? 6 and 85/100ths plus some amount is equal to 10. All right. So again, my mind, or at least when I was younger as a student, I so badly wanted to say it's going to be a 4 and something because 6 plus 4 is 10. But I need to always remember, no, we have a little bit more than 6. So this will start with a 3. And then what do I have to add to 85/100ths to make it a full whole, which is still missing here? I know that that will be 15/100ths. All right. Yes, there you go. Thank you. All right, let me pose a few more for you here. We'll look at some subtraction statements with decimals. So I'm going to give you 13 and 95/100ths minus some amount is equal to 10. What about 10 minus some amount is equal to 7 and 45/100ths? And then some amount minus 10 is equal to 7 and 25/100ths. Go ahead and share that with me. Again, if you're following along with the worksheet that was shared with you, these are all in there. Just maybe 2 corrections I have to make on the first few problems, so we'll do that for you. These are all correct. So what do I have to subtract from 13 and 95/100ths to get to a 10? I can count up, right, from 10 to this number if I really wanted to. So that's using the method that some of you have been recommending to me in the comments of kind of doing the opposite operation. And I see the number popping up. That's right. So I subtract 3 and 95/100ths. Okay. If I subtract 95/100ths from 95/100ths, I get the 0, which is essentially here. It's just not popping up because it doesn't need to. And if I have 13 holes and I subtract 3 more holes, I get the 10. So let's jump to this one here. 10 minus some amount is equal to 7 and 45/100ths. Again, if you're more comfortable working backwards, you can go ahead and do that. Okay. Or another way you can look at it is if I'm going to have some part left over, what do I need to subtract from one of these holes to give me this part? Meaning, what is 45/100ths subtracted from 1? Okay, and if you can do that in your head, great job. I'll have 55/100ths, which means I'm left with the 9 holes left over. Minus 7 is 2 and 55/100ths. There we go. Beautiful. And what about this last question here? Perfect. So what I'll also write down here is some of you might have thought of this as 10, which is perfectly acceptable as well. And what about this last problem here? Something minus 10 is equal to 7 and 25/100ths. Very good job. It is 17 and 25/100ths. That's exactly right. It's very similar to some of the other problems that we saw earlier. If I'm just subtracting 10 from it, I'm going to have the same parts. And 17 holes minus 10 does give me back the 7 holes. All right. Now we're going to jump to our favorite, which is fractions. So let's look at finding the missing number in some fraction statements. So I'm going to remove this. Beautiful job, everybody. Hopefully we're all on the same page. What if I asked you 7.5 plus some amount is equal to 10? So if you were great with your decimals, you should be even better with your fractions. So what do we do here? So I have 7.5 of something. Again, let's just think about cookies. 7.5, and I want to add some amount to get 10 full cookies. So first what I want to start with is the part. So if I have a half, let's add another half to make a full whole because I see that this final answer, this final sum amount is a full whole number. That's going to give me 1 whole. Added to the 7 holes I already have is 8, which means I need 2 more holes. All right? And you can confirm that by saying, oh, let's see, 7 plus 2 is 9, plus a half is 9.5, plus another half is in fact 10. Perfect. Let me pose you a few more. 9.25 plus some amount is equal to 10. And how about 6.75 plus some amount is equal to 10? What do we get here? This one shouldn't be too bad, right? I'm almost at 10. I have 9 and a bit. What is that bit? It's a quarter. How many more quarters do I have to add to make up my next whole? 3 quarters. Because I'm so close, right? I have 9 holes and a little bit. Beautiful, Echo. Very good. And what if I had 6.75? Not too close to 10, but over half at least. What do I have to add to it to get to 10? Well, let's make our next whole number. 6.75, to get to the next whole number, which would be 7, I'd have to add a quarter. Wonderful. Once I get to that whole number of 7, how much more do I need to get to 10? A 3. All right, very nice. Let's do a few more fraction problems. I'll erase this. What if we had, just need to keep track of what we worked on, 14.75, and I want to subtract some amount and get to 10. Then I have some amount and I want to subtract 10 and get to 7.75. And the last one here, 10 minus some amount is equal to 6.25. Let's go ahead and work on those. So this one, although it uses fractions, it's very similar to all of the other problems we worked with, whether there was a whole number here, a decimal, and a negative number. Maybe the slightest bit different when it comes to negative numbers, but we're still subtracting some amount to get to 10. And what is that some amount? This guy here. Yeah, close. So it's going to be the 4. Oh, I apologize. That is not correct. Let's do that again. So let's start here. So if I have 14 and 3/4 and I want to get to 10, one way you can think of this, and let me write this down, is 14 and 3/4, subtract 10. What is that amount? We can count from 10 all the way up to 14 and 3/4, which is another option. And I see you guys are sharing it. Very good. Okay. So what would we possibly get here? I see a few different answers. Let's see. I see 3 1/4. I don't know if that was from the previous problem. Yeah, that was. 4 1/4. All right, I see 17 and 3/4. That's for the next problem. Good. So what are we going to get here? 14 and 3/4 subtract some amount is equal to 10. Right, so I want to subtract that 3/4 amount because I don't have any parts here. Good. And my 4. Sorry, I'm seeing a bunch of different answers now. It's getting a bit confusing which ones you guys are answering. Let's go here. You guys have 17 and 3/4. I'm seeing that one. That one looks like it's for that question, so that's good. And what about this one down here? I have 10 subtract some amount is equal to 6 1/4. Right, so I can have 6 3/4 here. A few different ways to look at this one. I can look at 10 subtract 6 1/4 and see what that gives me. And if you wanted to check this answer here, you could just calculate 6 plus 3 gives me 9 wholes. 1/4 plus 3/4 gives me a whole. 9 plus a whole gives me the 10. All right. Good that it's so easy. Very good. All right. So let's remove this. And if you're following along the worksheet, there is a problem number 25, which is a very long one. I'm not going to write that out. I want to jump to our multiplication and division. But if you're up for the challenge, maybe Vidya, if you're up for it, go ahead and try that one out, all right? And you have another one like that in the practice problems as well. So let's jump to a few multiplication and division problems before we end for today. So what if I asked you for this missing number? So if you guys found the addition and subtraction easy, I'm hoping you also find this something you're super comfortable with. So how could I find this? What could I possibly do to approach this problem? Even if you can't tell me what the answer is, what if you share with me maybe some method that I can use to find this answer? Where is it? The worksheet was attached. It'll be the top comments at the end. It'll be shared by Mathnasium as a PDF that you can download later and follow along with and practice more with. Okay. So one way that you can tackle this is 288 divided by 12, very nice, yes. So that was one of the methods I was hoping to hear from some of you, because some of you shared with me the trick that you know, right? So when you're trying to fill in some of these blanks in these statements, you can kind of work with the opposite operations. So instead of trying to play around with numbers and think some number times 12 is equal to this number, I can just easily take this, divide it by this, and get this blank amount, which is exactly correct. But if you're super comfortable with your multiplication, one thing that you can do fairly quickly is think, okay, I as Sandra, know that 12 times 12 is equal to 144. I know my perfect squares very well. I know my multiplication tables to some extent very well, but I definitely do know that 12 times 12 is equal to 144. And a beautiful observation you can make here is 288 is actually double the amount of 144, which means instead of even having to do this division, I already know that this is going to be 24, because this is 2 times or double the amount of 12 times 12. Pretty cool, right? Pretty cool to always work with some of the easier facts that you know and see how they can help you out with some of the harder questions, or more challenging questions, I should say. All right, what if I then posed you with some number times 3 is equal to 2001? Again, I could write out a division statement and go ahead and try to perform my long division. I don't know about you, I try to stay away from division. I'm not the biggest fan. And plus, I like to exercise my mind up here. So I like to play around with doing my mental math and trying my best to get to this answer, and then maybe confirming it with division if need be. So how can I possibly find out what this is? How could we approach it? One thing that I can do, so I'm going to erase this problem up here. So one thing when I was preparing for this lesson, because I like to always try these problems out on my own and see how would I tackle it, right? So one thing that I would do, and what I used to do as a younger student as well, is see how close can I get to this amount, right? But using just the knowledge that I know. So for example, I know that 6 times 3 is equal to 18, which means that I know that 600s multiplied by 3, or tripled, is 1800s. That's very close to 2001. If I went to 700s, because I know 7 times 3 is 21, I know 700s times 3 is 2100s. That's a little bit over. But at least I know that my answer lies in between 600 and 700. Right? So my next number that I would work with all in my mind would be maybe 650. 650 times 3. Well, I know 600s 3 times is 1800. I know that 50 3 times is 150. So if I add those two, I get a lot closer to 2001, and I see the answer popping up. It is 667, Vidya. Very good job. And if I kept on playing around with this, my next number that I would try would be 660 times 3. Then I would try probably 665 times 3. And I would see I'm so close. If I just add 6 more, I get to 2001. And I'd be able to figure this out quickly. And I know I'm writing it on the board, but I would be able to do it all up in my mind. Seems like it might take a little bit longer than the division, but I promise you it's a lot more fun. So let me erase that and pose another problem for you. Let me ask you this one. I love seeing that you guys love math. It's very nice to hear students love math and enjoying math. All of us at Mathnasium love to hear it. Hi, Madhav. I apologize for calling you Vidya. I understand you're probably on your parents' account. How about you guys help me out with this problem here before we end for today? I want to do a few more of these. So I have some amount. If I take it and I add it 4 times, I get 10. Already you might start to think, okay, that's kind of strange, right? If I take 1 and I multiply it 4 times, I get to 4, so I need to increase this. What if I did 2 4 times, I get 8. Then Sandra, if I do 3 4 times, I get 12. So it's somewhere in between there, right? And I'm just doing this in my mind. 2 times 4 is 8, 3 times 4 is 12. 10 is in between 8 and 12. So how could I use that reasoning to figure out what this blank is supposed to be equal to? And another way you could look at this, if that doesn't help you out too much, is to say something 4 times is equal to 10. Well, if I put a 2 in there, I get 8. And then I'm going to put my knowledge of fractions together and say I know a half plus a half gives me a whole, which means I get one whole from here, one whole from here. So I actually get 8 plus 2, which is the 10. So this answer is 2.5, which you guys are sharing. And you could do 10 divided by 4, absolutely, if you're super comfortable with that. But I'm always just scared when students jump to that because I really want to make sure that you understand why that works. And that's exactly because of this, right? If I take 10 and I divide it up into 4 groups, what has to be within each of those groups? All right, so if you're jumping to the opposite operation, I love it. I love that that's your takeaway. Just make sure you understand why you're doing it. Alrighty. What if I then asked you, this is a cool one because it has decimals, and we know we all love decimals. What if I asked you this? So again, I'm going to jump before any of you say it, hopefully. Yes, I could pull out my, I'm going to say the bad word, the calculator. I could pull it out and I could plug in 6 and 25/100ths and divide it by 2 and 5/10 and get my answer. But I'm not going to do that because I don't need a calculator when I got the best calculator up here. What I could do is possibly work with division, long division, but then it's decimal long division and that's no fun. So I'm not going to do that. I'm going to use my brain power to figure out what this should be, given what I know about my multiplication facts already. For example, I know that 2, or let me rephrase that, 2 and 5/10 doubled gives me 5. That's close to 6 and 25/100ths. I like it. If I go 3 more times, that's going to be past it, so I'm not going to do that. But I realize here that the difference that I still have to accommodate for is 1 and 25/100ths. Does this look like it relates to 2 and 5/10 in any way? And I'm going to say absolutely it does. How does it relate? If you look at 1 and 25/100ths and 2 and 5/10, it's actually half the amount. Which means that I don't just take double the amount of 2 and 5/10, I also take half the amount. Let me write this in here. Pretty cool, right? And so I get 2, and I'm going to say it the way you guys might say it, 2.5 times 2.5 is equal to 6.25. I don't like that. I'm going to say 2 and 5/10 times 2 and 5/10 gives me 6 and 25/100ths. And isn't that pretty cool that we did that all without a calculator? Let's do maybe 2 more. And again, there's a lot more in the follow along page. I don't want to keep you guys here too long, but let's maybe jump to some division problems. So let me actually give you, or ask you, some number divided by 15 is equal to 20. Then I am going to ask you, this is maybe a bit of a tricky one, but I'd love to see what you guys come up with, and then we'll end it there for today. Okay, so how do we get to this one here? Well, something divided by 15 is equal to 20. So again, some of you might jump to, you might already be doing this on your paper in front of you, 20 times 15, which will give you the answer here, absolutely. But why does that make sense? Well, let's see what we know about division. So there's something, let me draw that something. I don't know how big this something is, but I know that when I divide it into 15 pieces, let's see if I can count 15 pieces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think that's 15. Then each of them is worth 20, which means to find my answer, yes, I take 20 and I multiply it by 15 because each of these cells contains 20, I don't know, dogs, cookies, whatever it is. And so I do get to my answer of 300, but the reason this makes sense is because of what we know about division. Okay? And then let's jump to this last one here. Oh, wow, I see someone helped me out. It is 15. I love that you got that. So this answer is 15, but I'm going to call this one a little bit tricky and challenging. And don't worry if you feel that way. I would absolutely agree. As a student, I would find this a little bit tricky when I was younger, because it's not the friendliest looking division question that we've worked with, right? Why is that? Because we're not dividing by a whole number, we're actually dividing by a decimal number. And what do we know about decimal numbers? They show us parts. And it's kind of weird to take a whole amount and divide it by 3/10, which is exactly what we're looking at here. Let me move this up here so I can erase it from below here. So for those of you that maybe learn more visually, which is absolutely myself, which is why you'll always see me pull out my manipulatives or my drawings. I always need to make sense of the math that I'm working with. So how do we make sense of something like this? Again, I could pull out my calculator and I could do the opposite. I could work with the opposite operation. I can pull this to the other side for those of you that have been working with equations already. And I can multiply by 3/10, or I can change this to a fraction. And yes, I will get 15, but why? So again, I have some amount, remember the previous image that I drew, some amount divided by this amount gives me 50. The only issue is that we're working with tenths. So the way that we're going to actually display this, and let me see if I can draw a great visual here. So I'll take a whole and I'm going to divide it up into tenths. Why? Because I'm only working with tenths here. I could divide into hundredths, but there's no need to right here. So I'm going to draw my tenths. And if you don't feel comfortable drawing it, I can pull out my handy dandy place value blocks. I can pull out my hundreds. I can pull out my tens, and I can work with them. I just wanted to show you really quickly with an image, and then I'll pull those out in just a second. So what I could do here is find what amount divided by 3/10 gives me 50. So what I'd have to do, and I kind of did this on my page before, is draw a few more holes, and you'll end up finding that I have 3/10 here. So let me do this. 3. I have another 3/10 here. Then I have 3/10 here. Then I have only 1 here. But if I take 2 from here, I have another. Then I'll have another 3. I'm just going to keep going just so I can show you. Then I'll have 2 from here. Then 3. Okay. And I'm going to stop there because I've used up some whole amount. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But how do I go from 10 to 50? I multiply by 5, which means it's going to take me 5 times 3 wholes to get to this answer. Just for those of you that kind of need that visual. So 3 times that 5 amount gives me that 15. Okay. I know this one's a little bit more tricky, so feel free to go back to this lesson, pause it as needed, and see why this visual makes sense. As I said, pull out for yourself some place value cubes, reach out to nearest Mathnasium to see how you could possibly use some online manipulatives to help you out with these instead. I'm going to leave it there. As I said, look at the follow along and practice page that is shared with you in these comments. Thank you, Echo, for sharing today your answers and helping us out with some of these math concepts. And Srikar, as always, thank you so much for helping all of us out. everyone else that joined us, I truly, truly appreciate it. I really love it when you guys start having these math conversations amongst each others and helping each other out. And for all of my Mathnasium helpers as well, thank you. I appreciate it. I'm going to end it there for today. Have a wonderful day. As always, smile loads, find math all around you, and tune in tomorrow for our next schoolhouse lesson. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.